Welcome back, guys. So, we were discussing insertion in red black trees, and in my previous examples, I told you how to insert, elements in a red black tree from scratch. So, we inserted nodes 9, 17, 6, 14, 15, and this was the final scenario which we went through in the last video, in the previous videos, and you can find the link of my previous videos in the description. So the final configuration which we encountered after insertion of node 15 was a tree like this, all right? For convenience, I will just redraw it again, okay? So we got node 9, 6, 15, and let me color it as, for convenience purposes, we had 14 and 17. So this was where we stopped earlier. All right. Now we are left with insertion of node 29. All right. Now, as per the conventional properties of the binary search tree, if we talk about insertion of node 29, so 29 will be inserted towards the right of 17. All right. And again, we see that two consecutive reds, two adjacent reds is a violation of the properties of red-black trees. Now let's focus again towards the rules of insertion. If the parent of the newly inserted node is red, parent of 29 is 17 and that is red. All right. So then check the color of the parent sibling. Check the color of the parent sibling. So sibling of 17 is 14 and parent sibling is red. It is not black or null, so we don't need to go for the first option. Okay. So if the parent of a newly inserted node is red, then check the color of the parent sibling. That means check the color of the parent sibling or the uncle of 29, that is 14, and that is also red, so we comply with the second property of rule number 4. So then what is needed? If the color of uncle is red, then recolor it. Okay, so recoloring of 14 is required for sure, that is fine. Now when 14 will be required to recolor, definitely we need to recolor 17 as well, right? Because we cannot have, we are encountering a violation over here with two consecutive reds, all right? Now, also check if parent's parent, that is parent of 17, that is 15. If parent's parent, that is the grandparent of 29. So who is grandparent of 29? That is node number 15. Is 15 the root node? No, 15 is not the root. So we need to recolor it and recheck it. That means we need to recolor the grandparent also. All right. So, and then entire rechecking is required. That is why in this particular case, when we recolor and rethink about the proper formulation, what do we have? Root should be black. Fine. Now, we need to recolor the grandparent. The original color of grandparent in the previous step was that 15 was black. A recoloring is required. Alright. So we will recolor 15. Alright. And we need to recolor 15. But 6 will remain as it is. We will not recolor 6. Alright. And then if a node is red, both its children have to be black. So 14 is black and 17 is also black. And the newly inserted node will always be red in color. So we have 29 as red in color. Alright. Now let me just prepare the sentinel nodes also. That is the leaf nodes also, so that I can just verify that are we complying with all the properties of the red black tree. Okay, step by step. So I'm again repeating that the moment we inserted 29, so because 29 is greater than 17, we inserted it towards the right position. All right. Because the tree was non-empty. So when the tree is non-empty, create the new node as the leaf node and color it as red. So we inserted 29 and colored it as red. So we encountered that two consecutive reds are noticed. Now we come to rule number 4. If the parent of the newly inserted node, who is the newly inserted node? 29. So if parent of 29, that is 17, is red in color, then check the color of uncle. Who is the uncle? Node number 17. Is the uncle black in color? No. So, or null? No. So go to second property of rule number 4. If the uncle is red in color, so we need to recolor the uncle, and we also need to check the parent's parent, the status of parent's parent. Now, who was parent of 29? 17. Who is parent of 17? Node number 15. Is the grandparent the root node? No. If it is not the root node, then we need to recolor it and again recheck that whether we are complying the property of the red black tree. That is why I recolored node number 15. There was no need for me to recolor 6, so I left 6 as black. So now we have node number 9, 6, 14 and 17 as black, and I have node 15 and 29 as red. So now let me just go through all the properties of red black tree. Root is always black, yes. Nodes are all either red or black, yes. If a node is red, then both its children are black, yes. Fine. Let's check the black height of node 9. If I go for checking the black height of node 9 on the left subtree, and again I'm repeating as I did in my previous videos, that whenever we compute black height, we do not consider the node itself. So how many black nodes we have in the left subtree with respect to node 9? Black height of node 9 towards left subtree, one black node for 6 and second black node for the left leaf node. Alright, so I have black height is 2. Then again if I check another path, one black node for 6 and another black node for the right leaf node. So black height is 2 in the left subtree. If I check in the right subtree, the black height of node 9, one black node, because I'm not counting 9, so one black node for 17, another black node for the leaf node of 17, so 1 and 2, fine. If I go with another path, one black node for 14, another black node for the left leaf node of node 14, 2, fine. If I go with the right leaf node of node 14, so one black node with node 14, another black node with the right leaf node of node 14, 2, and similar I go for, if I go down, one black node for 17, another black node for the right leaf node towards the bottom of node 29, and another black node with 17 and another black node towards the left leaf node of node 29. So black height of node 9 is 2 towards the left subtree also and towards the right subtree also. So that is how we comply with all the respective properties of the red black tree. Alright. Now for deletion in red black tree, stay tuned for my next video, and the links for all my previous videos are available in the description. Thank you guys.